Hello everybody, and welcome to today's webinar, Meeting PCI DSS Network Security Requirements in Kubernetes Environments. Welcome, thank you for coming, and I am pleased to introduce today's speaker. We have with us Vince Lau. Vince has over a decade of experience helping healthcare, financial services, government, telecom, and retail manage cybersecurity risks. He is responsible for Tigera's content and for the go-to-market strategies. He took his MBA from Santa Clara and has a bachelor's in computer engineering from Cal Poly San Luis Obispo, my alma mater also, so go Cal Poly. And also he is a CISSP. So, without further ado, excuse me? Yeah, okay, we're good. Without further ado, I'm going to hand it over to Vince. Vince?
Thank you, Michael. Go Mustangs, right?
Yeah.
All right. Thank you again for the introduction. And with that said, just want to go over a couple of interesting stats that I came across preparing for this webinar, right? The first one being, some of you probably have seen this, the cost of non-compliance has significantly increased over the past few years, and the issue keeps getting more serious. And this is a report in regards to, compliance versus cost of non-compliance issue from the Ponemon Institute. And at the current moment, it's over probably 2.5 times more to be non-compliant than compliant. Now, you must be wondering, hey, what are some of the reasons why, right? Now, tons of reasons why, but I think one of the reasons being is that there isn't really a firm understanding, especially within the Kubernetes space in regards to compliance. And I think this situation will continue without further education on both the practitioner side and also from the auditor side. And don't take my word for it. Let's take a look at an actual recent news article. So here's an interesting story, right, where Anna Kalin, she's a system engineer at Paybase, explained how they went through an end-to-end payment, audit or compliance exercise to achieve PCI DSS level 1. Level 1 is extremely difficult. This is a top tier certification that you can get from PCI, and it basically entails the most amount of cardholder information that that tier involves. Now, she ran it on Google GKE and all this stuff, and besides kind of addressing some of the Kubernetes security shortcoming, another crucial factor, like we mentioned before, was addressing the challenge of the status quo PCI requirement. As you probably have read by now with this particular excerpt that I pulled from this article, she basically was doing the exact right thing, right? You can see that she was using network and pod security policies, but she had to persevere and convince, the auditor that, hey, what is defined as the server in the PCI spec is actually a pod, right? So we can kind of see that from both a practitioner perspective and an auditor's perspective. There is a level of understanding that might need to be achieved in order to do a proper compliance. So, ladies and gentlemen, I think we're at the forefront of meeting, coming to an agreement on some of the compliance, specs in regards to Kubernetes and traditional workloads in the new age of this environment. And the good news is that, achieving compliance can all be addressed through a proper understanding of this spec, right? And also understand how Kubernetes environments differ and behave, and also, most importantly, some of the tools that can help solve these issues. And so, like Paybase did it, right? So can we. And this is kind of the part where I say, hey, you know what? Last slide I said, don't take my word for it. This is the part where, hey, take my word for it, and let's go on this journey. I kind of myself been both a practitioner and an auditor, and I think having both sides of perspective, the level of understanding is very, very important. So with that said, this is the journey we're going to be going on today. What's kind of changed in the Kubernetes environment? So let's just understand, hey, like Anna was going through, hey, a server, a pod, what's the deal, right? And then we're going to actually go through the PCI requirements and understand some of the challenges that we've seen, some of the challenges that you guys are probably facing, and then each one of these actually will go through the solution and tool set for meeting some of these requirements, right?
Great, Vince. Hey, listen, I just want to say, in all the excitement of getting Vince going, we passed over a few housekeeping items. The most important being, if you guys have any questions, please ask them as they are going, and we will try to answer them in real time. We also will have a Q&A session at the end where we will handle any and all questions that come at us. So, without further ado, let's get to the main presentation.
Great, no problem. Thank you, Michael. Thank you for doing that. So with that said, we left off at kind of talking about the tools. All right, let's jump right into what's kind of changed, right? If you look at this slide here, prior to Kubernetes, we've kind of basically been working with very static environments, right? You can look at this as a bunch of servers here. Racks of servers ran applications into traditional networking devices, switches, firewalls, all of them. And these things, quite frankly, didn't change a whole lot, right? So even if we went into the more recent IT, so to say, approach with virtualization, like taking virtual machines, more dynamic, but things still existed long enough for them to basically have accountability, especially when it comes to audit, right? So accountability is key, right? You have something that essentially didn't change over the course of after an audit between cycles. So things used to be measured in, calendar, quarters, potentially years based on, what your audit requirements are. Obviously, they're more frequent, less frequent. So you can do basically a compliance report and you can evaluate your environment and see what's plugged into that, see what firewall rules exist, go to an audited environment. And, most audits involve spending time, I'm sure many of you have been there before, days or weeks collecting the data because, things didn't change that much and you come back and say, hey, this is where we are and, we should be good to go for maybe another cycle. So essentially, compliance has been built with auditing and reporting, assuming longevity of these will be sufficient to say that you're, again, compliant over a certain period of time. Now, let's take a look how Kubernetes, changes that from a compliance perspective. So, this is the comparison between the old traditional workloads versus, container-based workloads orchestrated by Kubernetes. So modern applications on the right, very different from traditional application. You can see just the number of boxes. That alone gives you an idea, hey, there's a lot of components here. Like I said before, traditional applications used to be, have this long-lived workloads kept for months, years, or even longer. Now things are very short-lived. Workloads only need to run when they need to. It's not like they'll just sit there idle. When they're not needed, they're gone. With traditional application, they used to be more monolithic, right? Most of the work were done with maybe in-memory functional calls. It basically just reside on a particular box, so your functions never really went over network. Now, with modern application, things are all on the network. And I think probably preaching the choir here. Everything's done via API calls over network. So then, this is a completely different environment. The overall view here is that we have a lot more things, basically in motion, and microservices much more dynamic than they, old traditional monolithic applications used to be. So what does this really mean, Vince, right? So let's move on. All right, this is the implication here. Just some stats so you can get an idea how dynamic the container environment is, right? Containers are lightweight, much faster. In terms of start time, they have much shorter lifetimes as well. They just come and go whenever they're needed, right? So whereas VMs and servers used to be measured by, months, these are now potentially measured by seconds, minutes, and essentially much shorter lifetime. Looking at 900, potentially 900 faster startup times on average serving a container versus a virtual machine. And now you've got this thing where you might have 80, 100, maybe even, we've heard of 1,000 containers per server. Whereas in the past, you've seen, I don't know, maybe 8, 10, 20 VMs on a server. That's, we're talking magnitudes different here. So you can reasonably assume that you can have at least tons more components here, basically opening your, increasing your attack surface, right? So you do the math here, much greater churn, your endpoints are changing much more frequently. And so then what does that mean for the compliance aspect, right? So if you think about this, this is a really important point. If your environment's changing this frequently, how do you know if things are compliant after you do an audit? There's just how do you know, right? Your application was great 10 minutes ago, which brings us to this slide. And now they're like, hey, there's a new code that went out there, and I don't know if I'm compliant anymore, right? So in this very dynamic environment, you kind of can't just rely on the fact that you can do maybe an audit or two in a year and think that, hey, you're compliant. You kind of have to start thinking, hey, you know what, compliance is actually a continuous process here. What was compliant 10 minutes ago might not be compliant 10 minutes after with a new push of the code from your developers within the CI/CD pipeline. Okay, so that's kind of the state with where things are. Let's kind of jump into the specifics with regards to PCI, right? This obviously webinar is about the PCI aspect. So just a little bit of a quick overview. So PCI standard basically requires entity that store, processes, transmits, cardholder information, anything that you guys actually, everyone owns your credit card numbers. Basically those numbers and your information, those are very sensitive information, right? You don't want that out. Cardholders or the card network doesn't want that information out. Obviously charges, malicious charges or fraudulent charges can occur when that happens, obviously privacy, all that stuff. And so basically PCI DSS cover systems that handle all cardholder data, whether in motion or systems that, are data that's in rest. And how they do this is they segregate the environment, right? They say, hey, you have to define what they call CDE, which is a card data environment, and an access control to the CDE, right? So it's this zone where it's like, okay, hey, this is where it's very sensitive, important data. Let's do everything we can to protect that information. Click the next slide here. So here are the detailed specs with regards to what we saw from an overall perspective. There was 10 items. Don't worry, we're going to actually go through each one of those sections, and you'll see that overall slide again with the specific section we're going through. I just want to take a minute here to tell you, to highlight the fact that there's a detailed spec below that, obviously. And we won't go into the specific, like this level of detail here. This is not the intent of this webinar. But what we've done is we've consolidated these into groups so that's easier to understand, hey, from a broad PCI ask perspective, what the challenges are and what the solutions are, right? So this is exactly what we kind of mentioned before with the journey, what we want to do. All right, so we're going to start off with the first group. We've done a little bit of mapping here in regards to some of those, sub overall themes in PCI. So this one is around building and maintaining a secure network, right? So basically here you can see an image of a firewall. Essentially, PCI requires network segmentation and isolating CD environment from the remainder of an entity's network. And you can see here it clearly spells out firewall all over the place in the PCI spec. There's nothing wrong with firewall. I want to make sure that we're not saying, hey, firewalls are bad or anything. This is just how the specs were written. And the thing is, PCI spec's been around. Containers is new, so it's subject to interpretation, right? If you look at how traditional firewalls handle workloads, it's difficult. It's difficult to configure, it's difficult to manage because of the fact that it leverages static IP ports and ranges, right? We go back to our old traditional environment where things are more static. You can define basically identity around potential IP, a port. And most importantly, the IPs rarely change, right? You guys, those you're technical, you go into, your computer, you go, hey, assign me a DHCP IP, and, the lease time, much longer, right? With, containers, they change dramatically. Containers rarely have static IPs, they're built to fail fast, reschedule quickly, and basically, the static IP thing is out the window. And then this basically brings a whole different class of connectivity and security issue. What you see in the field is the fact that, hey, a lot of times, DevOps teams would need to push through a new set of code. There's changes to the Kubernetes environment, and they submit a change ticket with firewalls, and often it takes, a couple weeks to just get ports and IP open. And so that becomes a real bottleneck. And we've also seen, to alleviate this condition, wide IP ranges for firewalls, basically letting sets of IP addresses through from a Kubernetes perspective. So these things are, potentially not ideal. And here's another one where we're seeing lots of our customers actually deploy. Very common approach with handling PCI, given there's some limitations or some challenges in a Kubernetes environment with firewalls. So we often see separate clusters being used just to address PCI requirement. They completely build another cluster just for PCI, right? Now, this definitely achieves the objective of segmentations, isolations, all that good stuff. But it does become very cumbersome and potentially error-prone when you have this type of environment, right? You would basically have a lot of duplicate resource, essentially double, whatever you're trying to achieve with your prior environment, just to make this work, extra database, file storage, introducing lots of operational complexity, right? And I don't need to go into just the cost alone, hardware, software, all that stuff, manpower, just to meet this requirement. So if you look at the next slide here, here's the actual state in which I kind of really want to operate in, just taking a really simple example here with a single cluster, with single Kubernetes cluster. You basically want to be able to operate within that particular environment, but be able to say, hey, I want things that are doing PCI just to be able to talk to PCI, and things that are not talking PCI separated and don't communicate, right? I mean, that's the concept of isolation. So what we want to do is we want to be able to, one, identify everything that's covered, be able to block all traffic between these two, right, or between the ones that are PCI and PCI, and most importantly, allow traffic to flow freely between the PCI workload. Now the question here is exactly how we get there, right? And this is the concept of Kubernetes network policy, right? Kind of the policy as code concept here. Basically, network policy is specification on how groups of pods are allowed to communicate with each other and other network endpoints. It's similar to a traditional firewall. The concept's not that much different. It's essentially being able to restrict access. Basically, you can with this approach, you could write a firewall rule. But basically, you have to get an IP for the traditional IP with the traditional firewall, right? So in this sense, in a Kubernetes environment, we're going to take a really simple example here. Say, hey, you know what? Instead of IPs, we're going to actually obviously use IP. But let's make use of labels, right? Let's label these pods with tags such as like PCI. So when things are dynamic, right? When you label all these pods that come and go, and you have a PCI label, even when they're dynamic, they're constantly changing, and IP addresses are ephemeral, you need to be able to apply this set of policy and rules to things that come and go. So this is what we mean by declarative, is in regards to, hey, it doesn't matter how many things get spun up, shut down, whatever it is. That policy basically follows everything that's labeled with that metadata of PCI label, right? So that's what we mean by declarative. So lastly here, we want to make sure that when we describe these rules, that they can be repeated in automation. So I want to be able to use them basically in a declarative manner, basically in a CI/CD pipeline, right? So the entire configuration, we want to be able to describe it in like a file, basically a configuration file, like a YAML file, and basically let the underlying network, plumbing or plugin, what you want to call it, take the steps in enforcing those functions. So as you can see here, essentially, this entire concept of policy as code basically creates policies that can be introduced into the CI/CD pipeline, and you basically have control over how you want to dictate and drive traffic based on a concept of policies and label. And this is the part where I say, hey, don't take my word for it, right? You've actually seen this in the second slide we presented. You can see Anna from Paybase, they basically, hey, implemented this. And, the challenge area is, hey, you know what, so they obviously understand this is the right approach to do this. Challenge area is, with some of the auditors, hey, you know what, let's treat pod as servers. These are not traditionally the same as traditional workloads. And so, this is the education part where I think could be useful for both the practitioner and also the auditor, right? Okay, with that said, let's move along. So second component, or another grouping within building and maintaining a secure network, is maintaining, so to say, a current network diagram. Now, this network documentation is very key to a PCI assessment. So someone who's coming in and do the audit, right? It is one of the first requirements listed in the PCI standard. And why? Obviously, they want to make sure they validate that, hey, current diagram exists, and people know what connections actually can are set up or configured to the CDE environment. And so there's a process, they want to know what the process in place to keep this diagram current, because if things change, whoever is on the side of securing that data better be able to know where that data is going to. It better not land in unprotected space where it could become potentially compromised or jeopardized. Now, as you can see, there's a diagram here. This is a typical networking environment, just like how we mentioned, started off with some of the slides before. The challenge here is how can a static diagram like this keep up with containers, like we mentioned, right? How can things stay current when there's so much churn? All these pods comes and go in a matter of minutes, potentially seconds. So what do we do here? So this is the part where you really need to take another approach with looking at some of the other tools where you have better visibility in regard to understanding both the network and also the flow, right? This is one of, so to say, one of the biggest impacts of containers, which is why it's important to make use of that network policy we mentioned before to assign things with labels. So even when things come and go and move around, you have the tool sets to follow no matter what happens. Now, this approach is actually powered by the data that actually comes from defining the network policy and the labels, right? You can see that this provides you a network diagram in regards to understanding the namespaces, the labels, the metadata behind all the Kubernetes workload. So this one you can actually drill down and look at. All right, you know what? I've got set of pods in a particular namespace, so I got a set of pods with a particular label, and you can understand all the pods that falls in your PCI range. And you can see something along the lines here. You can see there's whiffs with regards to the graphs here. Basically, that's the data flow. How much data is flowing between different components here, right? Like how much data is flowing between namespaces, how much data is flowing between these PCI workloads. Documenting the data flow actually gives all of us a much better understanding of where card data is stored, processed, or transmitted environment, right? As well as identifying all supporting and connected system and device. This is something that actually helps troubleshoot connectivity issues, any security issues that might arise. In essence, without a proper network diagram with Kubernetes context, all of us risk potentially having the entire microservice environment being in scope for audit. And that's something that could be quite daunting. Not only would there potentially be a chance for having major or minor findings in your audit, you could end up doing a ton of work, which would be very unfruitful. Skip this bill. We kind of spoke about that piece. You will go back to this high-level overview here. We're going to move into the second piece about protecting cardholder data. So this one is fairly quick. One of them talks about 4.1 talks about data in transit, and so fortunately, Kubernetes does not come with any type of encryption between pods at the moment. You're basically left with using tools or third-party tools. I mentioned this is a very quick one. On the Tigera side, we offer capabilities to encrypt pod-to-pod traffic, and this is done via MTLS. So this is very easy. The benefit here is that you can turn this on without changing anything in the application, and it can be set globally on a node by node basis, right? So this is something that obviously very important to do, simple in terms of understanding concept, and let's make use of simple tools like I mentioned before. I'm going to move on to the third piece here, maintaining a vulnerability management program. So if you look at this section, this consolidated section, it kind of boils down to using, hey, IDS, IPS, and also reviewing logs for anomalous and suspicious activity. One of my favorite things kind of in the security space. So diving deep into the logs of IDS and IPS. Now, we can actually see that traditional logs only provide very limited information here. If you can see on the right-hand side, 5 tuple information. This is obviously not rocket science. You know that, right? If you look at this particular log here, I know the screen's a little bit, the image here at the bottom might be a little bit small. This is actually a screenshot from one of my favorite IDS tool called Snort, right? Open source Snort tool. You can see 5 tuple information pretty much everywhere, right? You've got, source, destination, port, and then obviously because the IDS, it actually analyze the packet and see, hey, what's going through, and now obviously it provides a description in regards to potentially what type of activity was happening in your environment to trigger that alarm. So now you see this in a Kubernetes environment. This information is somewhat useful, but not entirely useful. You don't have any idea which pod did what. It's just IP information, and we know for a fact that IPs are very ephemeral in a Kubernetes environment. So essentially, these logs that you get would become fairly incomplete and also inaccurate, right? Where connections being denied, Kubernetes could appear to be accepted, which is not what you want. So what you really want to do is take advantage of more data points, which is very important, and you need to have much better context, right? Like potentially with a flow log like this one. This flow log actually provides way more information compared to the 5 tuple information that we saw earlier. It's 24 pieces of information here. That's, I guess, if you do the math here, we're playing with math, that's about 5 times more data, so 5 times higher resolution. And essentially what you want to be doing here is you want to log the actual context in regards to what the pod is actually doing so that you get a much more accurate understanding of what's going on without having to worry about the false positive information I mentioned before about, hey, something that potentially said was allowed was actually denied at the pod level, right? So a flow log like this provides the deep visibility and it basically provides you with information, like I mentioned before, basically source destination pod, namespace, labels, what policies were applied, policy action bytes in, connection counts. So these are things that are very crucial when it comes to understanding containers, especially in a Kubernetes environment. Now, to take this further, we're doing a Tigera here in terms of, I mentioned here the logs, but anomaly detection. We also actually monitor for anomalous traffic based on this information. On our end, we see any type of port scans, any type of IP sweeps. These are reconnaissance activities in your cluster. And we will basically set up an alert and send it to whatever alerting medium of your choice, email, dashboard, Slack, whatever it is, so that you're aware of it. And we also integrate some of these threat feeds so that we can block malicious traffic from going out. So we actually, on the Tigera side, have both the flow information, the detailed high resolution context, and also the capability to help you detect these anonymous behaviors. Again, you see that in the prior example, looking at IDS logs from Snort, you can get the context in regards to, hey, some type of attack that happened, but what about the context? Which pod did what? We have absolutely no idea, right? Within the maintaining a vulnerability management program, it calls out detecting and preventing web attacks, right? So walk through explanation of these images here. And this is absolutely something that needs to be done. 6.6 basically said, hey, you know what? Install a web application firewall. And for those of you who are not as familiar with application firewall, they basically sit in front of a public-facing or any web application to monitor and detect, prevent web-based attacks. These solutions don't perform the functions like network segmentation, but they actually provide protection for the web traffic itself. So we're talking, restricting access to resources, maybe cross-site scripting, attacks like that. This is all great, But again, the challenge here kind of trickles down from the prior slide. The visibility aspect of it is going to be lacking. Obviously, the WAF's going to be giving you a lot of context in regards to the HTTP traffic, but then what about the actual pod context? The incoming connection land in a web application and it reached the pod, which pod did it go to? Yep, I mean, you don't know, right? I've worked with some of these projects, and I don't know. I've never seen, it's really hard to trace it. You have to do a lot of correlation. And on the right-hand side here, policy and policy, right? And obviously, you think about the concept of installing a WAF, then you have your network components, your network segmentation. You basically have two separate policies or potentially multiple policies. And we all know for a fact that the more disparate systems out there, the more policies you have, the harder it is to have a unified security approach. And it's just to make things harder for security teams to manage and also to get a good single pane of glass in regards to understanding what's going on, right? So these are the complexities that a lot of our customers and prospects face. So basically, you want to leverage a policy that unifies both application and network, right? This is something that you would then only have policy instead of two. You can define not only the service that communicate with each other, but also like from an application perspective, what URLs and web methods are allowed. So this is something that with Tigera provides in regards to unifying both the application and network policy into one. This is kind of something we call enterprise Calico policies, for those of you who know Calico. And then multi-layer checks are basically performed automatically. There's no need to write multiple policies. And these controls are very effective determining who is allowed to do what under what condition, right? So for example, a user can set a policy that allows service, let's say a service called PCI Auditor, to send, HTTP GET requests read only to maybe a web path like /card data. And then, they can do that while, denying service to all other services. And with this approach, earlier we mentioned about visibility. This is one completely unified, holistic approach in regards to managing finding access to both network and application, and obviously we capture layer 7 information. So you're getting context at the network level, layer 3, all the way to layer 7. So it makes it a lot easier when you're troubleshooting and managing these to have all the Kubernetes context associated with both the network and application logs, right? Makes it just, like I said before, I've been in the trenches trying to figure out a lot of times what happened to what, and the last thing you want to do is, have the security and kind of go, hey, is this what it is? I'm trying to figure it out, correlate. It's a time-consuming process. It's an error-prone process. Make it as easy as possible. So that's the intent with unified policy. Okay, we're moving down to, I guess, the fourth bucket here, implementing strong access control, right? So this section essentially talks about more people have access to cardholder data, the more risk with your CDE. So limiting access to those with a legitimate business reason helps an organization prevent handling accidental compromise of cardholder data, right? We kind of spoke about leveraging a network policy in the beginning of this presentation to define a dynamic PCI environment. So now let's take that concept further, right? And let's take that network policy further, because that's actually part of a zero trust model. You want to really, leave kind of container environment wide open where anyone can just walk in and do what you want. That's not what you want there. So I mentioned zero trust security, network security, right? Essentially, what we're talking about here is we establish trust on individual pods and services, all right? And this trust is based on multiple sources of identity data. We spoke about the fact before in the past, IP was your main source of identity data. We're moving way beyond that now in a containerized environment. You have to work off of multiple sources. Now, what we do here is we look at both cryptographic identity of the workload and also the Kubernetes identity of the workload itself, which is like a lot of things in terms of what we spoke about before, right? network policies, what part policy they belong into, namespace, label, all that stuff before we can establish trust. And so PCI talks about implementing a model of least privilege, and the way we do that is provide what we saw before, a unified policy model where you define fine-grained security access all the way from layer 3 to 7 for your application, so that you can go as granular as you want in your security architecture, all the way to the URL and web methods, defining some of these white list rules. So going a little deeper here, in terms of the defense in-depth architecture, how we do that is we do enforcement of these whitelist rules at multiple points of infrastructure. You can see on the diagram on the left, right? This is done at the host pod and the container level. So what the point here being, you say, hey, that's great. It's a lot. Well, it's really not, because if you think about it, in the unfortunate event, if your infrastructure gets compromised, like let's say somehow someone faked the identity of a pod, what happens then, right? With this approach, your application stays secure. There's that cryptographic identifier we spoke about before in regards to X509 cert that belongs to the application. So even if either one of those things get compromised, there's multiple layers of enforcement here that prevents that attack or that attacker or that attack compromised pod from gaining access to whatever resource there is. So this makes it a much, much safer environment in regards to restricting access in terms of least privileges, all that very, very important security concept stuff. We're not going to cover 12, so this is the last section we'll be covering, basically regular monitoring and testing networks, right? So this piece here, we take merge a little bit of concept here. We kind of spoke about the concept of like this, compliance being out of date, maybe within minutes. So this concept of continuous compliance, right? And it's going to tie this into the regular monitoring and testing, essentially tying into reports. You can see here I mapped out a few requirements from PCI in regards to some of these things that requires reporting, right? So there's a formal process for proving and testing all network connections. This is something that obviously you need to understand what workloads were kind of in scope. Next one talks about, hey, how do you manage access between DD and the internet? Prove that, hey, what is connecting to what? Know at least if there is an internet reachable connection, let's demonstrate that you can show where is it going. Inventory, obviously, that's very important. Understand what workloads are in scope, what workloads are not in scope. And lastly, record audit trail for all system components. So this particular piece here, we've seen with our customers and prospects as an activity that takes quite a bit of time, right? I've been there myself, trying to generate some of this information for an audit. And it's not easy a lot of times, especially when you're working in a Kubernetes environment, which encompasses traditional networking technology like firewalls, right? So this is a very time-consuming process. What you really want to do here is leverage, specific compliance reports when it comes to audit, right? And what we've done here, make things very easy. So a solution here is to kind of break them down by 3 different types of reports, right? Inventory report, network access report, and policy audit reports. Inventory report, basically, if you think about it, would help you drive to understand what things are in scope, not in scope. So, like I mentioned before, it's very bad if everything's in scope, your entire network or all your assets become under scrutiny for PCI audits if you can't show what things are protected by essentially what network policy, right? Even if you have the labels in place, you can't show it. You're gonna be stuck facing an auditor having to answer that difficult question. Network access is the one kind of mentioned before with, hey, where's this traffic flowing? Which workloads have access to and from the internet? And also, on that note, which workloads have access to other namespaces? And lastly here too, what endpoints have encryption, right? We talked about encryption being one of the PCI requirements. So these are things that you can pull immediately to see, what's in scope. Are you compliant? Are you not compliant? And lastly, policy audit is really important. The policy, network policy we spoke of, essentially acts as providing segmentation and segregation, right? So you want to see, hey, what happened there? Changed? What was new? What's modified? What was deleted? So with that, going back to the prior slide in regards to some of the requirements, you can see that you can easily map some of those requirements to the policy, the report types that we just spoke about. Excuse me. So these are some of the things that make the lives of, the compliance team and security teams a lot easier, a lot less error-prone, and reduce the amount of time required when it comes to an audit. And that's, good news when it comes to making things easy and more accurate. So I'm going to wrap up here. I know we spoke about a lot of some of the capabilities. Essentially, the capabilities I spoke about maps into 3 core buckets that helps address PCI network security. So the first one here being zero trust network security, where you can essentially whitelist all rules and communications for your Kubernetes-based workloads, and this hinges on the workload identity concept, leveraging multiple points of identity data, both cryptographic and also from the network perspective, in regard to labels, namespace, all that stuff, to truly establish a zero trust environment, restricting access, least privileges, and also providing a defensive in-depth approach so that even when things get compromised, not all of it gets compromised, right? You actually have different layers protecting access to application if the network gets compromised or the other way around. Second piece here is we provide deep visibility protection for the cluster. This is where you saw the 24 points of data compared to the traditional 5 tuple data that you could get from. And further note that diagram that you saw earlier in regards to the Kubernetes network diagram and network flow is powered by the 24 points of data that's provided, right? So you have an accurate understanding of what pods, what components are communicating, and also most importantly, the network flow. Understanding how much data is flowing between these components can give you insight into security issues, such as, hey, maybe there's a pod that got compromised, and also performance tuning and troubleshooting. So last but not least, we've got continuous compliance, which unlike the traditional approach where you do a snapshot-based assessment of your compliance, it's a continuous enforcement and visibility across the infrastructure. You saw that with the reports the types of report that we can provide, and those you can pull at any time to get an idea of what happened. So even if you've done the audit and things change in the next 10 minutes, you can come back and say, hey, look, I know exactly what happened. I know these workloads came up, these workloads went down, and that gives you all the information that you need in regards to understanding, hey, what happened at any given moment in time. So that said, I'm going to hand it back over to Michael to see if there's any questions that the audience might have.
Sure. Yeah, we have a couple questions actually from the audience. But before we do that, I just want to remind everybody that you can learn more about PCI compliance. We have a paper that you can go get. In fact, there's a link in the BrightTalk interface that you can get direct access to that PDF without having to fill out a form. You can go get that. And also, our next webcast is coming up June 19th in 2 weeks. We do one every 2 weeks, and it is on Kubernetes network policy and Tigera together for security and auditing. So let's get to the questions. So we have a question here. I'll just read it verbatim. So some form of policy-based security and authentication, ML and TLS, right, is provided by service meshes such as Istio, right? And so how do you compare the protection provided by Calico Tigera versus a service mesh, regardless of what it is?
That's a great question.
Complementary.
Yeah, and they're very complementary. In fact, the unified policy that you saw, Istio is part of our solution. So service mesh Istio is part of the Tigera solution when we provide that capability. You can see that Istio is great in terms of providing security functions at application level. We actually enhance that and augment that, giving more security, like a security control mechanism, fine-tuning control in regards to the network level. So they're very complementary. Both, Istio provides, like I said, doing a great job of using Istio security. It could be a lot better when you combine the two solutions to give it a more holistic, zero-trust network security solution.
Actually, I have a question. I've been sitting in on a few of these webinars over a year, doing 2 a month. So we talk about PCI compliance, but there are other compliance. There are a lot of other compliance regimes, right? So what about, are companies having to address multiple, compliance regimes at the same time, and how do you deal with that?
Yeah, no, that's a great question. So we kind of spoke about the whole concept of using network policy zero trust model in regards to addressing the network security aspect of it, and essentially this is something that you've seen. Hey, at Paybase they've done in regards to meeting the PCI compliance requirement, and it is going to be not a whole lot different than other compliance what you see in the industry, in the space. Most of them is going to call out for segregation, least privileges, all these things. So all these security components in regards to networks policy, zero trust, they all apply to many different compliance frameworks and requirements. In fact, in my past life, oftentimes you're going to be dealing with multiple. I'm pretty sure those of you on the phone, when you're dealing with one, you just won't be dealing with one. You're probably dealing with multiple, right? Something like ISO 27001, potentially GDPR. Obviously PCI is very industry specific. HIPAA is very industry specific, so you wouldn't have two of them together. But these things basically cut across many different compliance frameworks. So you meeting this particular one for PCI, chances are you'll be meeting the other ones for another framework that you're working with. And the most important thing is, like what Anna did, understand it well, and obviously work with your assessor and auditor to understand the implications of the new Kubernetes environment, right? Are you treating like server? Are they, the PCI spec, it calls out server. Is server a pod? I mean, essentially you have to work with both, your team and also the auditor to really have a firm level of common understanding around how this new technology affects that's been around for quite a while.
We had a question that came in earlier, actually. It said something around, can you explain what accurate logging? You mentioned accurate logging, and that, I understand that there are more data points beyond 5-tuple, right?
Yeah.
You can go beyond 5-tuple.
Correct. Yeah, so when we talk about accurate logging, this is something that you have to look at the stack in terms of, hey, where things are being stocked, right? Traditional 5-tuple gives you information in regards to, hey, things being stocked at the network level. But if you look at the Kubernetes infrastructure and environment, things can be stocked at the pod level. So here's something that you potentially could be shooting yourself in the foot if you rely on 5-tuple information. You can go to an auditor if they say, hey, can you show me what information made it through to maybe your Kubernetes environment, and all the logs that you have essentially say, yeah, allow traffic. But in reality, you could have proper blocking at the pod level, and you just misrepresented yourself and got yourself into hot water with a potential finding. So the concept of accurate logging is very important, because 5-tuple information not only give you incomplete view of what's going on, it also gives you an inaccurate view of what's going on in regards to traffic flow within your Kubernetes environment. So that's a very important concept to understand.
Okay. Well, I don't see any further questions from the audience, so I'd like to thank you all for coming. And please do join us in 2 weeks for our next webinar. If you have we have a contact us form. We also have a demo request form if you'd like to see some of this in action. We'd love to show you. So once again, thank you for attending, and have a great rest of your day. Thank you.
Thank you.